Hi, my name is Brett Smithley. Currently, I'm not teaching. I do wish to teach at the high school level and focus on fundamental mathematics, anything from algebra, geometry, probability statistics, math 1 and 2. Some standards that I feel that I'd be successful teaching would be the addition, subtraction, and multiplying of polynomials. uh, because it's pretty straightforward. You're adding and subtracting like terms, or you're using the FOIL method to multiply the polynomials. The second content standard that I feel I would do well at is modeling relationships between different quantities for functions. And in that, using graphs and tables to identify the key features such as intercepts or intervals, where the function is decreasing or increasing. And I think it's easy to show the students visually the connection between the graph, the table, or the actual equation, and it gives them an easy idea of what function is used for what. The last would be interpreting the average rate of change or slope. It's a very applicable, and I can associate that with numerous real world problems. So I chose to identify two slope activities. One is a lesson I found online. It was all inclusive. It gives information on activating prior knowledge. It provides an introduction, the direct instruction, numerous practice problems, and also an assessment that you could use at the end of the lesson. The second is a web quest I created in EDSU 512, hiking Mount Whitney by observing slope. We start at the Whitney portal and end at the summit. There's different sections along the way where I have students calculate the slope between those two sections and then do an overall slope analysis of the entire hike. Some standards that I feel would be challenging for me to teach would be the quadratic equation, where students are identifying the zeros for those functions. I think because you have rational, irrational, or complex numbers that would be defined as those zeros, that it may be difficult for students to understand um, those different numbers. The second standard that I find would be difficult is identifying the rotations, reflections, or translations using angles or shapes. I think some students may have difficulty visually representing those different movements of those shapes, and it may be difficult to get them to make sense of that. The third one would be proving theorems about triangles. There's numerous properties involved in the geometry of triangles, and I think to get from a question for them to prove a question true, there's more than one way to get to the end result, and I think that will create issues with some students in comprehending that. I found two lessons online that identify instruction for rotation, reflection, and translation, and those are listed here. The standards for mathematical practice that I feel are the most important for me, first is making sense of problems and persevering in solving them. Because first you have to understand the meaning or what the problem is asking. Then you must identify and evaluate the given constraints and everything involved with the problem. Third, you need to develop a plan to solve it. And then number four, during the solution, you may have to adjust course, but that's the part of persevering in the solution of the problem. The second mathematical practice that I value is a model with mathematics. So it's always showing students the application of what they're learning and how it relates to real world problems. And third is look for and make use of structure. I find it extremely important to identify patterns and using those different patterns and applying them to solving problems and letting the students know that there's more than one way to attack a problem. The benefits teaching for Common Core, I think coherence, where they show that you're building on new information based on what you've previously learned. Also, there's a greater focus on fewer topics. So teaching 70% of your time is spent on major standards. Some deficits to teaching that I feel some teachers might associate with Common Core is relying on prior knowledge, where you have each subject is no longer standalone, and now you have linked progressive processes between the different standards. And also inclusion of all students. So you're shifting from a rote computation skills to creating a deeper conceptual understanding of the content. And that may be extremely different than how some teachers were teaching in the past. Reflection for me, I learned teaching is a continuous process. There's still a lot that I don't know. I also learned that I have a hard time translating the written standards into my own personal math knowledge. Also, I reflected on how to break each lesson down to cover a certain content standard. Like how many days of instruction does one standard require to achieve mastery from the students? And then also not having teaching in a classroom, it's difficult for me to identify different activities or lessons that I feel would be effective. And then here are my references. Thank you.